exercise 1E question 2. Given the figure with the resistor R is connected to inductor N in series with a constant E. Okay. In the first question, we have to obtain the first differential equation for the current I and T at the time of T. Firstly, we have to use the formula VR plus VN equal to E. Secondly, we have to substitute the formula VR is equal to IR and VN equal to N EI over T. This is a formula, so we have to substitute in this formula, the first formula. And secondly, we have to divide all this with N. And it will give us the equation for linear equation. And that it will give us PT equal to Rn and QT is E over N. Then given is I equal to E exponent integrate R over L dt is equal to E exponent RL over T times T. Then we will get this, we will use this formula I times T equal to integrate QT times I dt. If we substitute it, it will become in this formula that we show here. Yes. We will get exponent E over L times exponent power R over L T. It will give us, if we solve the integration, it will give us E over L bracket 1 minus E the power of negative T over RL, and it will give us this I equal to E over R plus C exponent R over L T. C is a constant. Solve the differential equation for the initial equation where the time is 0 and I is 0. Okay. As we get from the previous equation, I equal to E over R plus CD. C exponent of R over N T. Okay. If we substitute 0 and T is 0, I is equal to 0, we will get this equation. Is 0 equal to E over R plus C exponent power 0. From this equation, if we solve it, we will get C. C is equal to negative E over R. From C equal to negative E over R, we will substitute back from this previous equation, the first one. Okay. Then we will get this equation, which is I equal to E over R minus E over R exponent the power of R over L T. For this, we will factorize E over R because they both have E over R. So we will simplify it to become IT equal to E over R bracket 1 minus E exponent RT over N. For the question 3, what is the value of I as T approach infinity? If T is approach infinity, we should use a limit. This I, E limit is infinity d over r times 1 over d r infinity minus l. As we know, this will become infinity because everything that's divided and multiple with infinity will become infinity. As we know, exponent of infinity will become 0. So it will become e over r 1 minus 0. So we will get e over r, which is this I equal to e over r. That's the final answer. Assalamualaikum and hi. Okay, today I will show that the question that I'm going to show to all of you is we have to show that the parallel circuit can be modeled with this formula. Okay, as we know, the Kirchhoff law is Kirchhoff current law state that IR plus IL plus IC equals to E. Okay, so the question asks about the parallel circuit. The circuit that given is LC, the inductive type of circuit. So this is the common equation that we should know. Then, based on this equation, we know that IL is equal to C dV over dt, and IC is equal to integrate of V over L dt, and E is this, because is just same as like we differentiate it for the first time. And then after we got this, we should differentiate it like this. So C dV over dt will become C d square V over dt square, and when we differentiate the integrate of VL dt over L dt will become V over L. The differentiate will cancel out the integrate, and then 0 will become 0. So the equation is shown that this equation can be modeled with the LC circuit. Okay, after that we will proceed to the next question, which is given omega squared is equal to 1 over LC. Okay, the first question that we got, the equation is C d square V over dt square plus V over L equal to 0, right? Okay, then based on the question, we move this side to the other side, so it will become V over L equals to negative C d square V over dt square. Okay, then to make sure this become this, we brought C to the bottom of the V. Okay, so next it will become V over LC equals to negative D square V over dt. Okay, and then after we got this, we can see 1 over LC is equals to omega square. So we can brought V outside, and then 1 over LC will become omega squared equals to negative D square V over dt. Okay, then after this, we brought this to this side. Okay, we brought this to this side, and it will become after we got this, we brought this to the left hand side, so it will become d square V over dt plus 0, or we should say plus omega square V equal to 0. Okay, so this will become like that, as we have learned earlier in our class. That will d square V over dt will become m square. It will become m square
plus this omega square v. D square v over dt square will become omega square, and omega square v will become omega square. It's just the same as linear equation. Okay, so after we got this, we put it on calculator, and then we got this. After that, we can use the formula that I've given in our textbook, which is the third. This is the third case. V will equals to exponential of a0 a cos omega t plus beta sin omega t, and then exponent of 0, power of 0 will become 1. So this is the final answer. That's all.
Assalamualaikum, and hi, and right now I will do exercise 3D. Question number 1. The question is, from the circle, prove that this equation from this loop. Okay, firstly we need to do KCL. As we know, it is I1, I2 and I3, and we do equation I1 equal I2 plus I3. After that, we do KVL from this loop in left loop. From the left loop, we got this equation. From this equation, we arrange and input the formula. We got this equation. After that, we got this equation. We arrange, become like this. The final condition is number 1. Okay, from the right loop, we got this equation. After that, we got this equation. We input the equation. We will get this, but we have integration this here. We need to eliminate the integration. We must differentiate this equation, and we become like this, the final one, and this equation number 2. And after that, we got two equations. We substitute the equation number 1 to number 2, and this question number 1 we equation number 2 substitute, and we got this equation I prime 2. And after that, we got 3 equation. We use the formula and put the equation we got early, and we will get this equation. After get this equation, we see this equation is same like this equation, and the equation is proved. Okay, that's all today. Bye.
Assalamualaikum, my name is Muhammad Kimi, and I'm going to teach you about the application of Laplace transformation in electric circuit. So in exercise 4D for question 2, we got a circuit here, and the voltage source is 24 volt and the resistance is 12 ohm and the inductance is 4 Henry. So as we all know that the formula of inductor is L di dt plus the formula of Ohm's law VIR equals to the voltage source. So we all know that the inductor here is 4 Henry plus R here is 12 ohm equals to 24. So we transform it to the Laplace transformation equals to 0. And we all know here the derivative of the Laplace transformation, y equals to ys. But if the y got a differentiation, it got a different minus 0. It's same as like here, equal minus I naught plus 12 is equals to 0. And we all know here the formula of the Ohm's law is V equals to IR. So from that we want to find I naught based on the Ohm's law. So the I naught is 2 ampere. Back from the equation, we know that for SIS plus 12IS equals to 2. So we factorize this equation and we got 4s plus 12 equals to 2. So we brought it to the other side and we got 2 over 4s plus 12. Next, we factorize it to the 1 over 2 in bracket 1 over s plus 3. In this equation, we must do the inverse Laplace to get the real answer. So we know that if 1s plus a equals to exponent at minus. So the answer here is 1 over 2 multiplied by the inverse Laplace of this equation. So this is the correct answer that we all got. So that's all for me, Muhammad Kimi. Goodbye and salam iftar.